So guys, this over here is the touch button. See, it's off by default, but once I press it, LED turns on and it remains on. That's the difference between this and the previous button. It's like latching button. It will remain on until I do not press it again. See, now this top comes with a button. It is to add to the beauty of the project. See, I press it, it turns on, else it remains off. See, and you don't literally have to press it. You just go near and it turns on. See, it's beautiful thing, simple as that. So let me show you the code how it's working. So let me zoom in. So guys, you can see that first we initialized our LED pin, then we initialize the button pin, then we check if the button is pressed. If it's pressed, then we turn on the LED, else the LED remains off. Simple as that. So this programming gives us this result over here. So guys, hello guys, welcome to learning microcontrollers. In this video, I will show you how you can interface a PIC16F877A microcontroller with a capacitive touch anti-interference button. These buttons are very easily available. They look like this. As you can see, it has one module as a button, and the other one is a cap. It comes in different colors to add beauty to your project. It's basically to add some beauty to your work. Rest you can just press it with a finger as well. So it looks like this from the bottom. So guys, as you can see, we have like 3 pins here: VCC, ground and output. Now guys, let me label them for you. Left one is the output, center one is the ground, and right one is the VCC pin. Now these buttons are easily available in the market. I was unable to find what the model of this button is called. So I'm just gonna show you the image. So I don't know what the model of these is, but I will show you how to interface them. Now these are like a latching button. Once you press it, it remains pressed. Then you press it another time, then it gets released. It's like a push pull button that you push it, and until you do not pull it, it will remain pushed. So guys, this is our touch button, and this is the PIC16F877A. Let's develop an interface now. Let me show you how to do the wiring. So guys, as you can see, it's labeled as well already. Let me label it again for you. The leftmost pin is the output, center one is the ground, right one is the VCC. First of all, you connect the VCC pin directly with the VCC of the PIC, because it works at 3.3 to 5.5 volt, while PIC will work at the same voltage. So you just give the power from the PIC. Now ground will go to the ground of the PIC like this, and for the output pin, you can use any available digital input output pin of the PIC. I'm going to use the pin number D2 like this. Now to display the output and for the purpose of demonstrating, I will be using a 5 mm crystal LED. So we will program this circuit in such a way that once the button is pressed, the LED will turn on. Once the button is pressed second time, the LED will turn off. In this way, our programming will be demonstrated. Now guys, this LED has 2 pins, one longer, one shorter. So the longer pin is always the power and shorter is always the ground. Now to connect it with the PIC, you will need a safety resistor. It can be of any value from 100 to 500 ohm. I'm going to use a 220 ohm. You can use a higher value resistors as well, but higher the resistor value, the dimmer the LED will go. Now the longer pin of the LED will go to the one end of the 220 ohm resistor like this. From the other end of this 220 ohm resistor, you connect it to any available digital input output pin. I'm going to use a pin number D3 like this. Then guys, the ground of the LED will go to the ground of the PIC like this. In this way, our connections are completed. Before we move on to the programming, let me introduce you to the hardware. So guys, this is the hardware. This is the button. This is the LED I'm going to programming. That in the background is the PIC16F877A, and behind that is the PIC83. Now this is its cap placed on the table. I just peeled it off and it looks like this. It's basically for adding the beauty to your work. So guys, first of all, let's get to our MikroC for PIC so we can start with the programming. This is our MikroC for PIC. Let me zoom in so you guys can see better. So guys, go to the file, new project, and this window pops up, new project wizard. Click on next, write the name of the project, touch button tutorial by learning microcontrollers like this. Then guys, the next thing is, this is the path where your files will be created. Select the microcontroller. I'm going to use the PIC16F877A and write the name of the crystal that you are going to use. Since PIC16F877A don't have an internal oscillator, so you will write the value that is connected to the PIC as external oscillator. That is a crystal connected to pin number 13 and 14 of the PIC, and in my case, it's a 20 megahertz like this. Click on next and finish. Now guys, before you do anything else, first of all, save your work. Press Ctrl S and save your work. Now the next thing is, first of all we have two pins, one is for the LED and one for the button. Let's initialize the LED pin. Tris d dot, which pin is the LED and which is the button pin. Let's go back to the presentation and see that our pin number d dot f2 and d dot f3 are the two pins. Okay, d dot f2 is connected to the module, that is the input pin, and d dot f3 is connected to the LED, so that is the output pin. So go back to the programming. So d dot f3 is the output because it's connected to the LED. So give it 0. So this is the tris register, and tris, this is the port and this is the pin, and 0 means the pin has been declared as output and 1 means it's an input. For LED we need an output pin, and in Arduino it's just like a pin mode command, like pin mode input or output. Here it's the tris register. Now initially the LED must be off. We write port d dot f3 equals to 0. So the LED by default will be off. Give some initialization delay, not necessary, but I always suggest you give it in the one time loop. Now guys, we initialize a button, that is tris d dot f2 equals to 1. Now see the difference, tris d dot f2, that is the button pin, here it's 1. So the direction of the pin must be 1 because 1 means it's an input now. And by default we no need to give the default state because it's a touch button, it will automatically get the default state. So let's go to our forever loop now. Write on while 1, forever loop starts here, ends here, and inside it, first of all, okay, this bracket. Now first of all we check if the button is pressed. Now write down if port d dot f3, f2 double equals to 1, then what it should do, it should turn on the LED which is off by default. The LED at port d dot f3 becomes 1. Else if the button is not pressed, else the LED will go back to the default state, that is 0, this state. So just paste it here. So if the button is pressed, the LED will turn on, else it will remain off, connected to the pin number d dot f3, that is pin number 22 of the PIC. So we build this code. Okay, there is an error, let's check. Okay, we wrote a wrong bracket. Okay, it's fine. Now build the code. Okay, it's built successfully. Now we get back to the hardware. Let's burn this, go to the PIC16 programming tool. I will share you the link of videos in which I taught you how you can download and install free version of MikroC for PIC, and also this PIC16 programmer tool as well. So the links will be in the description, so you can download them free from those videos. Click on file, import hex file. This is the file we just created. Click on write. Okay, the new file is being written. Let's zoom out and get to the hardware. So guys, this over here is our hardware. So you can see that the code is written and the LED is off by default. See that we have powered up the circuit from the PIC16 programmer tool. See, it's powered up, it's on. So let's bring the finger near and see what happens. See, the LED turns on. Now it will remain on. Now that's the difference between this and the other module I made previous video on. See, it remains on once the button is pressed. While in that one, if you press the button, LED turns on, else it remains off. Now see that I again press the button, now it turns off. I press it, turns on. Now this is just to add to the beauty. See, it looks very beautiful when you place it in the front. It comes with the module. So that's the purpose of this. So you have to paste it on it or something like that. See, it has a bar here which will turn on the button once. See, you can press with this as well. See, so it looks very beautiful when you place it in front like this. See, it looks very nice. See, it's a beautiful thing, but I don't know how to use it. See, the button is working fine. See, once I press it, turns on and it remains on. Once I press it again, it turns off and remains off. Now I will press it, it will turn on. See, it's on, and now once I touch it again, it will turn off. So you don't literally have to touch it because it's a capacitive button. You just go near and turns on. See, I didn't touch it. See, no touching. I just went near. See, it's on, it's off. It's not necessary that you press it. See, it's very nice. See, so guys, this is it. This is how you will use this button. So if you have any questions, you can ask me in the comment. So I will also share the link. I will also share the code of this video in the description, so you can play with the code. So guys, we'll see you in the next video. Goodbye until then.